Next, we'll take a look at the kill command, and let's look at the man page for it first. And you see that the purpose of the kill command is to send a signal to a process. That doesn't sound nearly as destructive as the word kill does, but for practical purposes, usually what this is used to do is to stop a running process so that it isn't running anymore. This you could consider being equivalent to clicking the little X that's at the upper right of a window in a Windows-based system or some other computer. You click the X to stop the application running, right? And sometimes you might need to do that to restart an application if there's a problem with it. So you're probably familiar with that. But take a look at the synopsis here. As I said, we'll start to learn to read these a little bit. So the command is kill, K-I-L-L, space, and then the square bracket means that this may or may not exist here. Okay, in other words, it's optional. And what is optional? Some options. So you can supply options or not supply any options. And then this means that we're going to type something which is a PID. What is that? That's a process ID. And notice then, optionally, you've got ... the ellipsis, which means and more like that. So in other words, you could type kill space and then a process ID and hit enter, and that's a valid command, or kill space and then a process ID space and then another process ID space and another one if you like, and whatever for as many IDs as you want. That also works. Or you could say kill space and then insert some options and then space and then a process ID and then perhaps more process IDs. So you want to start to be able to learn these synopses and what they look like. So the description tells you that the default signal for kill is term, which means terminate, terminate. Use -L or -L, lowercase or capital, to list available signals. Particularly useful ones include HUP, which is hang up, int, that's interrupt, kill, which does what it sounds like, stop, cont, continue, and then 0. I don't know what 0 does. Alternate signals may be specified in 3 ways: a dash, a dash with a number, a dash sig, and then whatever the name of the signal is, or dash and then the name of the signal. So yeah, that's a lot of information, but what are these signals? Let's go down here. Oh, they don't have a list of the signals, do they? Where's the list of the signals? Okay, so it's not here. So let's see what we can do here. If we say kill -L as it suggested, now we get all the signals. Oh my gosh, there's so many more, right? It said some of the most common ones were like hang up, interrupt, etc. But you know, look at all the signals here. Yikes! And they all have numbers, but doesn't really. It's not that that crucial that you know all of the details here. Let's just use the ones that are the most important. So if I list all the processes, I'll combine the A, U, and X parameters for BSD. And let's take a look at something here. How about mint update? You have to be careful what you try to kill. In fact, I can demonstrate what will happen if you do something foolish. But first, let's send the kill command to mint update. You see right here on this line, it's process 2039. You have to know this process ID because that's the number that we're going to use. And we'll send the default kill signal, which is the terminate signal, to 2039. So I'll say kill 2039. And now then let's list the processes and look, mint update is no longer running. Okay, wasn't that fun? Very easy, just fire and forget. So if you'd really like to do something entertaining, go ahead and find the kind of base cinnamon process, the one that started the other desktop processes, and send a kill signal to that. and see what happens. Just be prepared. If you actually were to try that, your machine will become completely non-responsive. Maybe you don't actually want to do it. But if you did, if something like that ever happened, then what you would need to do, what you would do if it was a regular computer, is you would turn it off and turn it back on, right? Or hit the reset button. So you do the same thing here. Machine, and let's see, where is it? Yeah, right here. Host R, or hit or reset right there. It's just like hitting the reset button on a physical computer. So if you ever get in such a state, you can do that. But don't just willy-nilly start killing processes. As you start creating your own processes, you might find times that you need to kill a process that's running. The other thing to note is that sometimes if you have a process that's really running away, that means it's not listening to anybody, it's not accepting any signals, and it's using more and more CPU or memory, and you really need to stop it now. You often want to send a more forceful command, and you can do that with the instead of the terminate signal, which asks the process to terminate. It says, hey, will you please stop? And it's saying, no, 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 I'm not listening to you, I'm not listening to you. So then you send it the kill signal. So that would be the 9. So it'd be kill and then -9 and then whatever the process ID is, whatever the number is, 1, 2, 3, 4, 5. And that basically kills it with impunity. It doesn't matter whether that process wants to stop or not. Now, why would you have different ways of doing this? Well, it could be that a process is actually running and doing something useful. It might have some resources open, like for example, it might have a file open that it's writing to. And if it's in the middle of doing that kind of stuff and you send it a terminate signal, if it's a well-behaved application, it'll receive the signal, it'll say, okay, yeah, hang on just a second, and it'll stop it or finish its write operation, close the file, and then it'll say, okay, bye, and kill itself. That would be the proper behavior for an application. So sending the terminate signal is certainly preferable. But again, if it's something that's consuming all the system resources and running away, it's not well behaved, and we just need to stop it doing whatever it's doing, kill with the -9 option, that is sending it the actual kill signal, terminates unconditionally no matter what else is going on. Continuing through Chapter 4, as these videos are getting a little lengthy for this week, I'm not going to spend a lot of time on monitoring disk space, mounting media, etc. This is pages 96 to, let's see, 96 to about 102. I don't want to spend an enormous amount of time on that just because I think you can read it in the text and get the flavor of it and know that it's there, but it may not be the most important for the purposes of this class. Likewise, as we get to page 102, the section on sorting data is very interesting. There's a command called sort. You type S-O-R-T. You can, of course, check out the man page on sort, and it sorts text files by lines. And there are various options that can be used there to change the behavior of the sort operation. So read through the section on the in the book just so that you're familiar with it. At least read through it kind of quickly. But we can leave that one behind for now too. But one that I don't want to leave behind, that I definitely want to pick up on here in Chapter 4, is searching for data using grep. So if you're in the text, I'm looking at pages 107 and following, the grep command. Now, like many things in the Linux world and the Unix world before that, grep has a really terrible name, but it does actually stand for something. It was kind of a semi-acronym. I think it's what, a global regular expression, or global search regular expression and print, or something like that. I can't remember exactly. You can look it up if you're interested. But basically, what it allows us to do is to specify a pattern to search and then specify a file or files in which we want to find that pattern. And if that pattern exists, then it prints out the context of those occurrences. Let me give you an example that's a little more useful. If I take a look via ls here, I see that I have right here the file lorem from before. Remember what that looked like? How do we see what's in there? How about cat lorem? Like so. That was the kind of content that we had, okay, in the file. So what we might do is look for certain content within that file, and we can use grep to do that. So how about we do grep vitae in lorem. So I'm searching for every occurrence of the word vitae in lorem, and you see here it has highlighted all of the instances of that within the context of the line that they're on. Now remember, in this file, each paragraph was its own line. There was no carriage return until the end of each paragraph, and so the line is actually fairly long. Let's take a look at the man page for grep. So as we look at this, you can see that the grep command has an optional set of options, a required pattern, and then an optional list of file names. So what happens if you don't provide a file name? It says that in that case, if no files are specified, so you can see it right here, or if the file dash is given, grep searches standard input. That means whatever you're typing in. By default, it prints the matching lines. We saw that where each of our paragraphs was a line by itself. Okay. As we scroll down through the options, there are a lot of options for grep. We're just touching it right now. We're not going to spend an enormous amount of time on this right now, but let's see what we can do. The -C option suppresses normal output. Instead, it only gives a count of the matching lines for each input file. Okay, if you use the -V for which also means invert match, then it counts the non-matching lines. So it would be the opposite. So we can actually try that before we do anything else. Let's do the same thing, but let's add some options. We'll say -C, and there's our pattern, and whatever it says, 9 lines match. You remember how many paragraphs were in there? I think we had 17 paragraphs of text, right? So if I invert that, hopefully I should get 8, right? Nope, 26. We had a lot more lines than I thought we did. So it must be 35 actual lines in the file. Now there's a great deal more to grep, and we will be covering that later in the course because we'll be looking at regular expressions in some detail, and we'll learn how to use this. This is actually a power tool that has an enormous number of uses, and we'll be using it to good effect a little bit later. But for now, I just wanted to touch it so that you'd have some idea, and let's go ahead and move on and not belabor it too much. Last of all, we want to talk about archiving things, and it's very handy to be able to archive files for portability, being able to move them around from one place to another, or backing things up. One thing we might want to do, for instance, is back up our home directory. Remember that typing pwd, we can find out our home directory, or where we are. The default is the home directory. The tilde means that as well, as you will recall. If I list everything that's here, I see a variety of things here, and let's say that I wanted to basically back up the entire home directory, and maybe I'll just put the backup right here in the home directory. So how would I do that? I can use the command tar, which stands for to archive. So tar, the most common commands here, and you can check out the man page for a lot more, but C-CVF are the things. C is to create. F is going to direct the output to a file, which is obviously what we want to create. V is going to list the files. So it's in verbose mode, basically. It's going to list the files that it's actually archiving as we do it. So we'll be able to get a good feeling that we got everything. And what do we want to archive? or what is the name of the archive we want to produce first. We can call this backup.tar. Generally, it's going to have a .tar extension. And now, what things do we want to back up? Well, we can say, how about home/Perry, like so, and boom, there it is. And if I type ls, then I see that I have something called backup.tar here. If I wanted to restore that, I don't want to do that at this point and re-overwrite everything, but if I wanted to restore everything to, say, an empty directory, or if I was reinstalling my OS and I wanted to go ahead and bring all this stuff back in, then I could just go back into the home directory here, and I would use tar-xvf. That looks the same, except that instead of -c, it's -x. C is for create, X is for extract. Okay, so that's pretty much it. There's also the -tf. What does that do? Lists all the files that are in the archive that you indicate. So these are there on page 111 in the text. One other thing I might point out, I'm just going to go ahead and delete backup.tar to kind of clean that up. Okay, so you don't have to do whole directories. It's not just for your home directory. You could also add a list of files, like I could use Perry1, Perry2, Perry99, and Lorem, for instance, and put those into an archive as well, just a list of files. I can also sometimes, when you want to send something from one place to another or store it long term, you might want to reduce the amount of space it takes by compressing it. And oftentimes you'll see this. Someone might provide you with a file, or you might download a file from somewhere which is it's been tarred. That is to say, it's been put into an archive, and then that archive has been zipped, that is to say, compressed, using a tool like gzip. And so you'll see a couple of different extensions on those. Sometimes it'll be, if the file name was file name, you'd see file name .tgz. So that's one possible way that you see that. Another way that you'll see the file, if it's been tarred and zipped, it would be file name .tar.z. So how do you produce those? Well, what you need to do is pass the output from the tar command to the gzip command, and then that's going to create a .tgz file. So let's try that real quick. We'll just use our lorem file. So we'll make something, we'll say -zc, and the z does have to go first, by the way. Sometimes you change the order of these parameters, they don't work as well. So -zcvf, so this is going to make a .tgz file that's tarred and zipped. And what do we want to call it? We'll call it lorem.tgz, and the file that we want to put in that archive and compress. It could be a directory, it could be my whole home directory structure, but we'll just do one file this time. We'll do that. It shows you the one file that was processed in order to make that, and I can listen. I see that there's my lorem.tgz file. To extract it, it would just be the opposite of that. In fact, I can just remove lorem here. See, now it's not there anymore. But let's now we can test and make sure that we had a good archive, right? Let's see if we get our file back. We can say tar-z, and what's the opposite of c? C is create, x is extract, so zxvf, and this will be lorem.tgz, and it says it processed the file lorem. I look at that, there it is. So my file is back and safe and sound. Okay, so that's it for Chapter 4. We'll next move on to Chapter 5 and look at parent-child shell relationships and subshells and some background activities.